This is Stan. Stan built a shrink ray.
It took 3 weeks and most of a hardware store.
Stan's plan is to shrink himself down to the size of an atom and see what's actually in there.
Science doesn't do itself.
That is not strictly true. But before Stan pulls the trigger, let's talk about what he's actually about to walk into. Everything you can see, touch, taste, or smell is made of atoms. Your chair, the air, Stan, all of it. Atoms. There are more atoms in a single grain of sand than there are grains of sand on every beach on Earth.
That seems like a lot.
It is a lot. Now Stan is about to shrink down and see them up close. Right now, Stan is standing on a molecule. Molecules are groups of atoms bonded together. The surface Stan is on? That's his own skin, made of water molecules, protein molecules, lipid molecules, all packed together.
I'm standing on myself.
You are made of approximately 7 billion atoms. That's a 7 followed by 27 zeros. And right now, Stan is small enough to see the individual molecules they form.
That one looks like Mickey Mouse.
That is a water molecule. 2 hydrogen atoms bonded to 1 oxygen atom, H2O, the most important molecule on Earth. And it does look a bit like Mickey Mouse.
Science.
Stan is now inside a single atom. And here's the first thing that should genuinely surprise you. Atoms are almost entirely empty space.
Where is everything?
If an atom were the size of a football stadium, the nucleus, the dense core at the center, would be the size of a marble sitting on the 50-yard line. Everything else is empty space, with electrons somewhere in the vast distance.
So when I sit on a chair,
You are mostly not touching it. The atoms in you and the atoms in the chair are almost entirely empty space. What you feel as solid is actually the electromagnetic force between electrons repelling each other.
I'm not real.
You're real, just mostly empty.
That doesn't help.
Those streaks flying past Stan are electrons. Electrons are negatively charged particles that exist around the nucleus of every atom. But here's where it gets strange. Electrons don't orbit the nucleus the way planets orbit the sun. That's a common picture, but it's wrong.
Then where are they?
They exist in probability clouds, regions of space where the electron is likely to be found, but you can never know exactly where until you look. This is quantum mechanics, and it was one of the most unsettling discoveries in the history of science. Physicist Werner Heisenberg formalized this in 1927 with his uncertainty principle. The more precisely you know where an electron is, the less you can know about its speed, and vice versa. The act of observing changes what you're looking at.
So the electrons know I'm watching them?
In a sense, yes.
I need them to stop.
At the center of every atom sits the nucleus, a tightly packed cluster of protons and neutrons held together by what physicists call the strong nuclear force. It is the strongest force in nature.
Those are protons and neutrons?
Exactly. Protons carry a positive electric charge. Neutrons carry no charge at all. The number of protons in the nucleus determines what element you are. 1 proton makes hydrogen, 6 protons makes carbon, 79 protons makes gold.
So if I added a proton to carbon,
You'd change it into a different element entirely. That's what happens inside stars, a process called nuclear fusion. Stars are essentially giant element factories, fusing lighter atoms into heavier ones under extreme pressure and heat.
stars make gold?
Most of the gold on Earth was forged inside dying stars billions of years before our solar system existed. The gold in every piece of jewelry on Earth was made in a supernova explosion.
I need to rethink how I feel about stars.
Here's where it gets truly strange. Protons and neutrons are not the smallest things. They are made of even smaller particles called quarks.
Quarks.
Quarks. A proton is made of 2 up quarks and 1 down quark. A neutron is made of 1 up quark and 2 down quarks. They were first proposed by physicist Murray Gell-Mann in 1964 and have never been observed in isolation. Quarks are always bound together inside protons and neutrons. held by a force carried by particles called gluons,
Gluons.
because they glue the quarks together.
Scientists name something gluons.
They did.
I respect that.
Below quarks, we reach the edge of what we currently know. Whether quarks are made of something even smaller, whether there is a truly fundamental particle with no internal structure at all, is one of the open questions of modern physics. We may be approaching the bottom of the rabbit hole, or we may have barely started.
How far does it go?
We don't know yet. Everything you have ever touched, everything you have ever been, is built from particles so small that billions of them fit inside a single atom, which is itself too small to see. And most of it is empty space, held together by invisible forces we can describe mathematically, but never truly visualize.
So everything is mostly nothing, held together by forces we can't see, made of particles we can never isolate, governed by rules that change when you look at them.
That's a pretty good summary of atomic physics, yes.
I'm going to need a bigger drawer.